Hi children, we have already completed 2 chapters from your textbook. In the previous chapter, we have discussed about motion and 3 equations of motion you learned. Right? So, now I have got a doubt. What is motion? Yes, if an object changes its position with respect to time, then we call the object is in motion. Isn't it? That is what we discussed in the previous section. Now I have a doubt. If I keep an object on the table and which is at rest now, is it possible for that object to change its position by its own? Or if it has to do so, what we have to do? Is it possible to change its position by its own? Here you can see a box I kept here. Is it possible for this box to move by itself or to do something to make it to move? Yes, you know that to move this box I may have to push it or I may have to pull it, isn't it? So make an object in motion, or to bring an object in motion at which is at rest, we have to push it or pull it. Push or pull is called force, that you learned in your smaller classes. So push or pull acting on an object is called force, isn't it? So every force can change the position. Can every force acting on the object bring it in motion which is at rest? Let us see. So here, dear children, see, I am applying a force here from the left side towards the right. So the object moves, isn't it? And here from the right side, again if I apply a force, it moves. So whichever direction I apply a force, the object will move towards that direction of force, right? And here, if I apply the 2 forces from the same direction, from the same side to the same direction, then it is easier for me to remove the object. Now, if I apply the equal force, here I am applying a force, it moves. Here I am applying a force, it moves. But if both the forces are equal, will the object move? I think will not. Okay, so the object will not move. Okay, if we both the side from opposite to opposite side in the opposite direction equal amount of force if we apply, the object will not move. If one of the force is greater, this force, suppose this from left to right, the force is greater, then the object will move towards the direction of that force. And if the other force is greater, it will move towards the greater force. If both are equal, it will not move. Okay. So, here to explain that, in your textbook, the lesson starts with some pictures and their explanation. Let us go through that pictures now. In the first picture, you can see 2 persons pushing a table with equal amount of force, 50 Newton and 50 Newton. And they are pushing in the same direction. The table moves towards the same direction of applied force. It is easier for the person to if both of them push the table moves easily towards the direction of force. Now in the second picture you can see 2 persons applying force from opposite sides. Both of them are applying equal forces 50 Newton from both the sides in the opposite direction. Will the table move? No, the table will not move. So here, what is the net force acting on this table? Here, 50 by one person. In the same direction, the other person also 50 Newton. So both the forces add up and the force, total force acting on the table will be greater than if it is applied by a single person. Okay, so here 50 plus 50, 100 Newton applies on the table. Net force acting on the table add up. If more forces acting in the same direction, all the forces will be add up. Okay, and here in this case, if the forces acting on an object if from opposite sides and in the opposite direction, the net force acting on the table is 0, on the object is 0 here, so the object is not moving. So here this is 50 Newton, from one side it is 50 Newton and the other side equal in the but in the opposite direction. So this can be considered, opposite direction can be considered as negative. Okay, so one is positive, the other can be considered as negative. So when we add both together, we have to find the difference between them and to put the sign of the greater one. Okay, so here 50 and 50, find the difference means we will get 0. Okay, so that is why the net force acting on the object will be 0 in the second case. So let us go to the next picture. Yes, children, here you can see the object table. One person is pushing it with a force 80 Newton. The other person pushing it with a force 40 Newton. So the total force acting on it will be 80 plus minus 40, that is 40 Newton. And here two people, 120 Newton and the other 120 Newton applying in the wrestling. So both will be equal, forces will be acting on each other. So both of them won't win. The force will balance. And here you can see in the tug of war, both the teams are applying force in opposite direction. These people will pull it in this direction. This team will pull in the other direction. So here the 400 Newton is applied. Here this team applying 300 Newton. So who will win here? Yes, the who applied 400 Newton. This team, the other team will fall towards it. Isn't it? And the net force here is 100 Newton. So this table you have to fill, children, as per the figure given. So here remember the first figure is 50 Newton. F1 applies 50 Newton. F2 also applies 50 Newton only. Positive, both are positive forces because both applies in the same direction. 50 plus 50 becomes 100 here. In the second case, one is positive 50, positive direction, the other is in the opposite direction, so we can take negative 50. So the sum of positive 50 and negative 50 becomes, total force becomes 0. And in the third case, 120, here third case, this one, 80, one direction 80. And the other opposite, that is why we can take it as minus 40. So positive 80 and minus 40 both together make 40, positive 40 Newton. And here 120 Newton and here opposite direction. That is why minus 120. Both together 0. And here 400 Newton positive. If we take this positive, this will be negative, negative 300. So both together make 100 Newton. So in which of the situation depicted in the picture did the total applied force become 0? Yes, it is 3.2 and 3.4. Figure 3.2 and figure 3.4. And does the body move in all these situations? No. In the second situation, the table won't move, and in the fourth situation, no, both will not win. Isn't it? So, no, isn't it? So, what kind of force can move the object then? Here, unbalanced. Here, 0. If the net force is 0, it cannot move. If the net force is non-zero, it can move the object. So, the net force, if the force is acting on the object, the net force acting on the objects 0, then such forces are called balanced force. if the total force or net force means total force. The total force acting on a body is zero. The applied forces are called balanced forces. Such balanced forces cannot bring any change in the state of rest or state of motion of a body. Only unbalanced forces can change the state of rest or state of motion of a body. Okay, children, hope all of you understood this concept. Two types of forces are there, balanced and unbalanced. The important thing you have to notice is only an unbalanced force can bring a change in state of rest or state of motion of an object. Okay, children, the next we will discuss in the next session. Till then, bye.